So let's take a look at this problem here. F of x equals 2x squared minus 4x plus 6, and we're supposed to sketch the function to determine the axis of symmetry. Okay, so what you want to do here first is we're going to take, I'm going to rewrite it as y. F of x is y, so it doesn't matter whether you call it f of x or y. 2x squared minus 4x plus 6. And what we said is when we want to convert it into vertex form in order to sketch it, what we want to do first is we want to subtract 6 from both sides. So y minus 6 equals 2x squared minus 4x. Now what I want to do is I want to complete the square. But to complete the square, the leading coefficient in front of x squared has to be 1. So I'm going to take each of these functions and I'm actually going to divide each of these by 2. By doing so, I will complete the square and sorry about that. I will complete the square and, or I'm not going to complete the square, I'm going to have a leading coefficient of 1. Sorry about that. Okay, so now I'm going to complete the square. So how do you complete the square? Well, you take this value here, the number in front of x, the coefficient in front of x, the coefficient in front of the linear term, and you divide by 2 and you square it. So that means I'm going to take negative 2, I'm going to divide by 2, and then square it. And what I do to one side, I'm going to do to the other. Now, it doesn't matter whether I put this value here or in the back. It really doesn't matter. It's via the commutative property. It's not a big deal. Okay. So then we'll clean it up. So we know that negative 2 divided by 2 is negative 1. Squared is 1. So this is just plus 1. And this would be 1 here. And the green is basically the same thing. So what is the point of this? Well, we're doing this because the goal is all of this becomes some quantity squared. And the process of completing the square makes it such that all you have to do is divide this value by 2, and you insert that here. So what I'm trying to say is that this, the parentheses, and the square will always be the same. What changes is going to be negative, because here is negative. And this 1 comes from the fact of this value divided by 2. And that is always true. Okay? So we continue this on the other side. On the other side, it's just a matter of me putting these together. So I have y over 2 minus 2. Okay? Now, vertex form has it such that y is by itself. So now I'm just going to play the game of getting y by itself, which means I'm going to add 2. So y over 2 equals x minus 1 squared plus 2, and then to finish it off, I'm just going to multiply everything by 2. And when we do that, we get these to cancel. That was the whole point. Equals 2 x minus 1 squared plus 4. Okay. Now the question is specifically asking about the axis of symmetry. The axis of symmetry is when this is equal to 0. So the AOS, or axis of symmetry, is x equals 1. So the answer choice that has an axis symmetry of x equals 1 is the correct answer. Oh, it's on a different video. Which is D. And there's our answer. Now there is another way to do this. We also said in a previous video or in class that if this is, well, let me call it HK. If HK is the vertex, then x equals h is the AOS, axis of symmetry. So if that's true, then if I can find the x component, well, how can we figure out the x component? We can take this equation here, we rewrite it, and we said the vertex, or the x component of the vertex, I guess I should say, is negative b over 2a. So if we look at this, we see that b is negative 4 and a is 2. So this is going to become negative 4 over 2a, which is 4 over 4, which is 1. And hence x equals 1. So that is another way of doing it. Keep that in mind. I do think that being able to complete the square, though, is a very important skill to develop and have. So hopefully all of this makes sense, and I'll see you in the next video.